Okay, hello everyone. We're gonna go over questions on the graphing FRQ that I put up. So the first question, if we look, it says it's given that g of x, oops, let me go ahead and, oops, I did save it. I'm gonna go ahead and bring up the right side. On the left side here, we're given the g of x is the integral of 0 to x of f of, that's probably f of t, something like that. F of t or f of x, variable f of x, nope, f of t, that's probably a t there, or L, whatever they want to call it, doesn't matter, as long as they're the same. So, okay, so what does the integral mean? Integral means, for us, a sum. So this is the graph of f. So the integral, g is just the integral from 0 to x. So from 0, here's 0, and where do you want to stop counting? If I put 1, that's all this. If I said 2, that becomes a 2. We're going all the way here. If I write integral from 0 to -1, and put this in red, we're going to go backwards from 0 to -1. And then if I go from 0 to -2, we go under the curve. Okay, so it really just depends on what value we want to plug in. So just that's the idea in general. Now the question number 1 says, g, what is the g of -1? So g of -1, we write that as the integral from 0 to -1 of f of t dt, where f of dt is the graph right here. So I want to zoom in a little bit. Okay, so first thing we normally do, A is usually less than B, and in this case it's not. So I'm going to actually rewrite the order. You cannot if you don't want to, but normally I like reading from left to right. So first let's switch the order, integral from -1 to 0 of f of t dt, just to make sure we have that order. So now if we go from -1 to 0, what is the area of f? Area of f from -1 to 0. Okay, what type of shape is that? It's a triangle. Triangle area of that triangle is half base times height. Half the base, which is 1, the height is 3. So our area is going to be -3/2. Or that's what g of -1 is going to be. Okay, because this is the area of the triangle. That goes in the integral, and don't forget the -1 in the front. The -1 goes in the front. Okay. Okay, let's look at the second one. The second one says g prime, and g prime is the derivative. Now let's go ahead and write that derivative. D over dx integral of, was it, we wrote 0 to x of f of t dt. Now, whenever you take the derivative of the integral, that's a fundamental theorem of calculus. So what happens to the derivative in the integral? If you remember, since they're opposite, good. And we just plug in x. So this is just f of x, which is now going to be -1. So what is the actual value of f of x? Looking here at the graph, zooming in, f of x at -1, we have, sorry, I should erase that. That looks like it should be like a 0. Okay, that's a 0 for us. So that's going to be 0. Now, again, this could be super tricky if you didn't remember this was fundamental theorem of calculus. And the derivative and integral cancel out. And remember, just plug it in. Hopefully, you guys kind of still remember that. Our next question is, what's the second derivative? So fine, after I find out what the first derivative, what is the second derivative? Oh, no, it's gonna do this crazy thing of -1. Well, we just find the derivative of -1. And the derivative is another way of saying this is the slope. So what is the slope of the graph at -1? And we can find the slope of rise over run. The rise is from -3 to 0, right? That negative 3 minus, darn it, it's gonna mess me up. Let me go ahead and close that, sorry. Yeah. Come on, do everything, stupid apple. There, close it. And then I'll have to reopen it. Okay, that should fix it. We have negative 3 minus 0 over negative 2 minus negative 1. Because I just picked the points, I use the points negative 2, negative 3, and the 0 and negative 1 and 0. These are the points here, 1, 2. And that's going to be negative 3 over, that becomes a negative 2 plus 1. Negative 1 is positive 3. 1, 2, 3 over 1. So my slope there would be 3. Now, if you look at the rubric, each of these are actually worth 1 point each. And 1 out of 9 points for a multiple choice is actually pretty darn good, I think. Sorry, 3 out of 9, that's not bad for a little bit of work. So the follow-up question is, for what values of x in the open interval from negative 2 to 2 is g increasing? Okay, g is increasing. Now, how do I know when g is increasing? Does g increase when it looks like this, or it looks like that? Well, increasing means implied a positive slope. Okay, our values are getting larger. Decreasing implies a negative slope. So we are given the fact that g of x, we said, was integral 0 to x of f of t dt. Well then, if I'm trying to find out the derivative, g prime of x is equal, as we mentioned before, is f of x, plugging it in. Now, when is g increasing? Well, when is the graph positive and when is it negative? So let's get to the graph. When is the graph positive and when is the graph negative? So from negative 2 to 2, when is f of x greater than 0? That implies that g prime, the slope, is positive. So it's positive here. Oops. Positive there. Between negative 1 and 1. Okay? And the reason why is because g prime is positive there on this interval. So for see what values of x in the open interval is the graph g concave down. Now, concave down refers to a second derivative. So we're taking the second derivative of g, again, careful, not f, because they asked us specifically of g. So we had mentioned that that's going to look like f prime of x. And when f prime of x, when the slope of f is negative, okay, that's important to us. We want the slope to be negative. So let's go back and look at the graph. When is the slope of f? This is f. Right, this whole graph is f. And we want to say, what is the slope? Well, what's the slope here? And what's the slope here? The slope on the left is all positive, increasing. The slope on the right is all negative, decreasing. And we want it specifically to be concave down. So when is this less than 0? It is less than 0 between 0 and 2. Oops. Between 0 and 2. Now you can also write this in this notation too, between 0 and 2. You can write in this notation if you're familiar with that. And that goes from 0 to 2. It's the same meaning as this here. Okay. Now for that problem, that was, okay, so to look at the rubric, we received 2 points on our last problem. If we, 1, stated the interval, 2, gave the reason. That's 2 points. We would receive 2 points. There's 1 point for this and 1 point for this. Okay, so that's we're at 7 points now. 2 more points to go. The last one, on the axis provided, sketch the graph of the closed interval from -2 to 2. Sketch the graph of G. So here's my G, and this part is the part that is kind of a little harder. Now, I'm going to draw the graph here also. Now, G is the sum starting from 0. So let's look what happens. At 0, what is the area at 0? Okay, when x is 0, what is the area as? From 0 to 0. Do we have any area at all? No, right? Remember, it's like a thin sheet of paper. And as I move to the right, do you think the area is increasing or decreasing? The area is increasing. So the value is starting to increase. Increasing, 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 increasing until 1. At 1, we stop growing, and then I start subtracting your area. Sadness. Till we end up back at 0, where this triangle are the same size. Now, a lot of people would have gotten the right side right. But I want you guys to talk about what happens on the left side. That is the part that is a little tricky. I think if we spend some time thinking about it, it isn't going to be that terrible. So let's go and spend that time right now. So let me get a little red pen here. So if I go from 0 left, what do we say happens to my integral? Do we end up adding values or subtracting values? It turns out these, as we did in our problem number A, at G at -1, it turns out we are actually subtracting values, and these actually turn out to be negative values. After a point, this becomes negative, negative becomes a positive, and actually looks like this. So that's again, look at y. The dx in this direction is actually going to be negative. So if I actually want to plug in the values, this f of x still will be positive as I go left, but the dx is now negative. And a positive times negative gives me a negative y value. A negative y value, because I am now going in the left direction. Okay. So the next FRQ question, okay, whoops, the last one, you would receive 2 points for specific points if you got 0, 0, and 0, making sure. If your graph was a little higher or a little lower, or even like kind of crooked-ish, they would still give you the credit. Okay? And they just want to make sure like you kind of got the idea what was going on. If you drew, they said if you drew a vertical asymptote, they would actually minus a point. So if the graph became a vertical asymptote, they would have minus a point because none of these slopes do not exist. Okay, let's go to the next one. The continuous function f is defined from the interval -4 to 3. Yeah, I see that. It's continuous. There are no breaks, no breaks, no breaks. It is not differentiable here, but it sure is continuous. And then it might have a vertical slope here, vertical tangent. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure below. A quarter circle, and then a line. Okay, I recognize those 3. Let g of x equal to, g of x is equal to 2x plus the integral from 0 to x of f of t dt. Find -3, g of -3. Okay, they told us find g of -3. I will not worry about that. I'm just going to plug in -3 into the problem. We see that's -6. And here I want to spin this around to make my life a little easier. So it's -3 to 0 of f of t dt. So what is the area from -3 to 0? This shape is I did a terrible job of that, but that shape is a circle, a quarter of a circle, So our equation is going to be pi r squared, and we divide that by 4, where the r value is 3. 1, 2, 3, pi 3 squared over 4, which is 9 pi over 4. That's going to be -6 minus 9 pi over 4. Oops, this is a really good microphone.
Could you just left it as pi 3 squared, like without?
Yes, you
Because I
could have
did
left it here. That's perfectly fine.
We don't have to do that.
You do not need to do the arithmetic. Arithmetic means add, subtract, multiply, and divide. You don't need to do those steps.
Yeah.
Same thing as the old AP, you don't have to do that here either.
Okay, just
and they actually encourage you not to do it. They say they don't want to take away points if you get the answer right, but you simplify wrong. They encourage you not to. Now, let's go ahead and move on. Next one. Find G prime and evaluate at G prime of -3. So G prime of X is the derivative. Let's go ahead and take the derivative. It's going to be 2 plus d over dx, integral from 0 to x of f of t dt. Perfect, because when I took the derivative, that gets rid of my integral, and we're left with 2 plus f of x. Whoops, don't you write that? F of x. And we want to plug in the value g at -3, g prime at -3. That's going to be 2 plus f at -3. Hey, f at -3, that's just the graph. And the graph at -3 is going to be 0. Okay. Okay, here we go. Determine the x-coordinate of the point at which g has the absolute maximum on the interval from -4 to 3. Okay, absolute maximum is when the derivative changes from a positive to negative. After we find that point, we always have to double check by comparing those to the endpoints. Okay, so let's go ahead and come up with a sign chart. So g prime of x, we said, was already going to be 2 plus f of x. Okay. Now, at what slopes would that become positive and negative? When will this be positive and when will this be negative? So looking at the graph, so we're going to say if f, let's say, was 0, isn't that just a positive value? Okay. And then we came up with the quarter circle. What did we say the answer was? Some value, let's see.
-6 minus 9 pi over 4.
-6 minus 9 pi over 4. That's all negative, isn't it? Okay. So, okay. Actually, no, we're just looking at the y value. I'm sorry. Looking just the y value. So, when will this become -2? If this is -2, we're at 0. So, are any of these y values -2? This is positive. Oh, this is negative, -1. But 2 minus 1 is still positive. So we're positive, 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 positive. How am I saying that? Is because every time I plug in a value for x, even if it's -3, what is the y value at -3? The y value at -3 is 0. So isn't 2 plus 0 still positive? What if I plug in this point here, -1? 2 plus -1 is still positive. 2 plus, look at this value, 3 is still positive. 2 plus 0 is still positive. But 2 plus -2, okay, -2 is like right here. That's when we all of a sudden become negative. Okay, so let's find out what that would be. This equation here, that's right, a line equation. To see what that value would be, I think we could do that. Y is equal to +3. Are you guys okay? That's my +3. And the slope is -1, 2, 3 over 2. negative 3 over 2x. And when will this value equal to negative 2? When will the y value become negative 2? Because that's what I need here to make this go to 0, to find that critical point. Remember that critical point? And so if I solve it, moving over the 3, that's negative 3 over 2x equals to negative 5. Multiplied by the reciprocal, x is equal to negative 5 over 1 times 2 over 3 negative. This becomes x is positive 10 over 3. Did I make a mistake?
Where did you get your equation from?
Rise over run. Oh, whoops, sorry. Haha, sorry. This slope is wrong.
Yeah.
The slope is wrong. Slope is wrong. Slope is wrong. I was thinking that was 2, but it wasn't. So the slope goes 1, 1, 2, 3, 4, 5, 6. 6 over 3. That's where my mistake was. Negative 6 over 3. Negative 6 over 3 is negative 2. X. And then, sorry, that's where my mistake was. So that's a negative 2x. Divide by negative 2, it's 5 over 2. So at 5 over 2 or 2.5, 1, 2.5, our y value is negative 2. Okay, at 2.5, our y value is negative 2. So that's the only critical point we have. So looking at a sign chart quickly, the f prime, sorry, not f prime, g prime, because we're looking at g, it goes from positive, 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 all the way to 2.5, 5 over 2. And then from here, it will become more negative. Okay. So seeing this, we know we have at least a local max at the local max at, what am I going to say, at 5 over 2. Now, how do we make sure this is absolute? Let's see, do they do anything special? Say G prime is greater than 4. I would then, for me, I would go ahead and plug in the 5 over 2.
I mean, it doesn't matter, but you have to check the endpoints, don't you?
Yeah, check the endpoints, that's why. So here's a faster way. If I give you guys, no, that's fine. Okay, so we know it's local max. Let's check the endpoints real quick. So what is G at negative 4? What is G at, what's the right endpoint, 3? And then if we plug those in, I think for sure it's not going to matter. But if I plug in negative 4, sweet, 8 times, darn it, I should write it, negative 2 times negative 4 plus the integral from 0 to negative 4 f of t dt. We're going to get that's a positive, I'm sorry. That's going to be negative 8 plus some value here. We know that the circle is going to be some huge value. I think that's going to be negative because we went left. So our value is going to be negative here. On the right side, we're going to say, hey, when we just add a max and we came back down, so even if I plug it in, we know this is going to be lower. So I think we're okay. You can also do the concavity test if you want, G double prime. If you do G double prime, if it's concave up or concave down, that can help you determine if it's a local max or local min.
I mean, can't you just see from looking at your little plus plus
Initial,
minus thing that like you can just
it
tell
never
it must be
turns.
minimums on either endpoint?
Yeah, so one thing we could do is, we actually had a rule for that before, that if the slope is positive leaving the left endpoint, this has to be a local minimum. And if on the right endpoint, if the slope is negative approaching the endpoint, this point had to be a local minimum also. You guys remember looking at endpoints? Okay. C, find the values of x with the interval -4 to 3 in which the graph has a point of inflection. Point of inflection is second derivative, and we actually did the math already, I think. No, we didn't, not this one, we did it for the last one. So G double prime will lead us to equal to, sorry, G prime of x was 2 plus f of x. So G double prime is f prime of x, which is just the slope of f. And we're asking, where's the point of inflection? Well, first thing, we have to figure out where this is 0. Looking at the graph, or 0 non-existent, right? So if you look at the graph, where does the slope not exist? Let's go ahead and look at the left here. At what points does the slope not exist? So every time it gets a little funny. So that looks like a vertical slope. This does not exist. Okay. So the question here is, at what points do we have a point of inflection? So when does the sign change from positive to negative? It says the sign change only happens at 0. Graph has a point of inflection at 0. So, darn it. So here is the point where it doesn't exist. And so if I look at the slope on the right side, what is f prime on the right side? F prime is negative. What's f prime on the left side? F prime is also positive now. So we do change from positive to negative. So we do have a point of inflection. So we say a sign change only at x is equal to 0. Do we have a sign change here?
No.
No, we don't. That goes from positive to positive. Okay. Okay. Find the average rate of change of f on the interval of -4 to 3. There are no points, but there is no point C between -4 and 3 for which the f prime is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, so f is this graph here. So they asked us to find the average rate of change. So the average rate is, all we do is we take y minus y over x minus x. Okay, this is an average of value, which is a totally different word. This is rate of change, which is another way of saying slope. So we say -3 minus -1 over 3 minus -4. The average rate of change is -2 over 7. Let's see, if I went down 2 and I ran 1, 2, 3, 4, 5, 6, 7. Yeah, that's the slope. Now, if we look at the graph, do you see any values here that would have the same slope? Because the mean value theorem says that if the graph is continuous, that the slope, the average rate of change must exist someplace in the graph. Let me give you one that looks a little more smoother. No, that's not smooth, that's ugly. Give a graph that looks like this. Okay, and I draw a average rate of change. Can you find some point on the graph that would have the same slope? Well, look at the point here. Look at the point here. You can. So can someone tell me why this rule doesn't work here? The graph is continuous, but we're missing one of the characteristics. Does anybody remember? it's not just continuous. It also has to be, anyone remember? If this is the slope of the graph, do I care that it's just continuous? Continuous is important. There's also one more thing. It also has to be differentiable everywhere. Thank you, Abner, you got it. Because it wasn't differentiable, this little corner stole all the derivatives that should have been there. See, it should have been here. But because that is a corner, not all derivatives are there. It has to be differentiable. And at -3, it's not differentiable. Also at also at 0, it's not differentiable. And that's the reason why. So you get 1 point for this answer here. Good job. And then you get another point, +1, for telling me it's because it's not differentiable at points -3 and 0. Because there is no slope at 0, because it's like a vertical line, because there's two circles. It's one circle talking to another. Those are vertical. You ever try, no, probably not. But you can imagine if you had a circle on the floor, isn't this corner like vertical? Right? So normally when you jump on a curve, you're always trying to jump up here. You never jump up down here because you just slide down.